California State University, Los Angeles, and Microsoft Azure. She'll be presenting a talk entitled Best Practices in Data Visualization. Please join me in welcoming Shilpa.
Good morning, everyone. I'm Professor Shilpa Balan, and I'm so overwhelmed with the crowd here, and makes me really nervous. And also I have like these microphones on me, so normally I don't have the microphones on me while talking. I'm normally already known to have a loud voice, but nevertheless, okay. So. As stated, I do teach courses in business analytics at California State University in Los Angeles. And while teaching classes in analytics and big data, I have seen students and some novices in the data science field trouble with understanding what good visualizations should look like. Because a common goal that most understand is that we take data to do some analysis, and then you have a visual. So, however, we want that visual to give us some insights that are easy to interpret and that we or any user of that visual could understand in several or few seconds of a glance. So, that led me to put some things together here for this presentation. Many of which are part of some literature review done by previous data scientists and authors, and some also of my experiences of what I think would be best practices for data visualization. Now, data visualization is an inevitable aspect of business analytics, and it allows the data scientists to converse with the end users. Now, not everyone would be comprehensible of the data, as they do not directly deal with the data. So in order to bridge that gap, data visualization makes people appreciate the possibility of the data analysis. So data visualization is an art of presenting data in a manner that even a non-analyst can actually understand it. So then what is it going to comprise of? So a data visualization is going to comprise of aesthetic elements like color, dimensions, and labels. And these would be the visualization masterpieces, and they can help a business analyst to reveal business insights, which automatically would lead to better decision making for businesses. So how would we define a visualization? So here is an interesting story, and it might help to define what's a visualization. So it actually leads to an old tale of 3 blind men. Now these 3 blind men, each of them touch a part of an elephant, and they have to describe what the elephant looks like. So one of the men, they touch the tail of the elephant, and they say that the elephant is like a rope. The other blind man touches the elephant's leg and says that the elephant is like a tree trunk. And the third blind man touches the trunk of the elephant and says that the elephant is like a snake. So actually all of them are right and all of them are not right. So in some way they are right and in some way they are not right, because they are just describing the animal that they really can't see. So data visualization is something similar, because we want the visualizations to be powerful, to give some meaning. So it's not just graphs, it's not just the visual metaphors, it's not just data analysis. It needs to give some meaning or some insight. So essentially, a powerful visualization, it should pass the elephant test, which means that it's practically impossible to describe, but it is instantly recognizable. Now, let's start with describing what's a data point. So data is not just about numbers, it's more than numbers. So to visualize it, you must know what it represents. So this doesn't mean that if you have data, you do some analysis and make a graph out of it. So let's take this slide, for instance. In this slide, we see that there are some stars. So these stars, they look like dots on a flat surface. So we can connect the dots. So maybe we perceive the stars at the same distance as us, but they are actually varying light years away. And if we actually see the actual distance, we see that the easily distinguishable constellations are practically unrecognizable. So the data looks different from this new angle, and so this is what context can do, because the context can change in the angle in which we see it. So the context can completely change our perspective on the data set, and I'm going to be talking more about the context in the next few slides. So it can actually help decide what the numbers represent and how to interpret them. So along with data visualization, of course, we also know that there is storytelling. So many of the key parts of the story, they are related as part of the process of placing the visualization in a context. So that means the context can provide answers to questions such as, what data are we looking at? In what time frame does this data exist? Or what are the notable events or variables that influence the data? This is an interesting and I think a realistic fact. A professor of marketing from Stanford University who states that stories are up to 22 times more memorable than facts. So storytelling and visual expressions, they are integral parts of human culture. So in the recent years, many have realized the storytelling potential of data visualization. News organizations incorporate graphs into their journalism. Television reporters also use visualization as a backdrop for their stories. So it's not just researchers and analysts and people working on data who are the only one concerned about making sense of data. So we want to make sense of data even in our regular lives. So if you actually see a light bulb, for instance, each of these light bulbs, based on their energy consumption, we can try to make sense of what the data of this light bulb looks like. Let the data speak. There has been some debate about this in previous literature, but overall, in my beliefs, we should let the data speak, which means that along with the data itself, and again, I'll be going over the next few slides later about narrative commentary that would add to the visual. But as far as we can, we should have this data speak for itself. So when you look at this data without any narrative commentary here, or basically without any really explanation over here, what would you infer from this data? Any guesses? It isn't too hard. I saw many of you with coffee cups. They're all espresso drinks. Okay. So basically the coffee mug and the steam illustration around each bar graph, they set the context immediately. So visualization has developed into a great way to tell the stories. So these coffee drinks that are illustrated in this figure, it is a good enhancement of the basic charts, and it provides the readers or the audience a connection. This is actually in the form of stacked bar charts, and for each drink, we also see that there are labels, and it makes it easy to interpret or gives more details about what the content for each of them is. So then, how does perception really works? Once the light has been encoded into the electric signals, the brain just extracts the main features. What does that mean? It means that as humans, we can actually look around at 180-degree angle. But if we want to look things or at objects, if we want to perceive objects, clearly we only see that within a 2-degree range, which is probably around front of us. But even for the remaining 178 degree, our eyes do perceive the objects in that it catches something that could be unusual. What could be unusual? It could be maybe a bright color, or it could be an uncommon shape in the visual. So it could be different things that it catches our eye. Let me show you an example. in this example, what catches our eye in the first part of the visual? The size, it's because of the size of that rectangle. On the second one, what catches our attention? The orientation, because we see that there's one rectangle that's orientated differently, and the third one is the color. So each of them had something different or something uncommon that could catch our eye, and that's what is pre-attentive processing. So we apply pre-attentive processing even to visuals, and we'll see that. So I will be showing you example of pre-attentive processing for the visuals, for data visuals in my later slides. So essentially, the question plus the visual data plus the context, that is the story. So most visualization stories, and I keep saying context again, so most visualization stories, they begin with some kind of question that orients to the context within the data that is most meaningful. So the context is going to answer questions such as what data are we looking at, or in what time frame does this data exist, what notable events or variables influence the data. So these are some of the questions that can context. Now, since we spoke about some things uncommon, but these are also some kind of thumb rules. In that, let's say if we want to represent something on maps, we could use shapes and symbols. So you see that actually gives us information about the Hurricane Katrina in the year 2005. And each of these circles over here, they have or they represent different categories from category 1 to category 5 of the hurricane. So even in the real world, the location on a map can be directly translated. So it makes sense to use icons to represent things in the real world. So for example, to represent forest, you can represent forests with trees, or you can residential areas with houses. So you could use different things to map the objects in the real world. There's always going to be some data uncertainty. So data uncertainty has to always be taken into account. And in order to explain data uncertainty, I have here a few cards, because I think most of us probably might have played a card game or two. So not really in a casino though, right? So, okay. So there's a dealer and a player, and let's say that the dealer deals a couple of cards, and a card or two can make either of them win the game. Obviously, they know what cards are there in that deck, but they do not know what the probability of the next card is going to be. So that is data uncertainty. Of course, data uncertainty is outside of cards as well when we talk about data analysis. But this was a way I thought I could explain the data uncertainty. So now, since we spoke about pre-attentive processing, another thing that would be related to that is that we want to focus on certain parts of the data. So the different data can mean different things to different people. So it depends on what the users of the data want from the data. So maybe some might be interested from that data to get, as you see, some information about the orders. There might be some audience who wants to get information about the price, or there might be some audience who want to get information from that data about something else. So again, the context really matters. Not all data is going to be useful to a user at a certain time. So we could actually focus on certain parts of the data. So when we focus on certain parts of the data, you want to highlight it because of the pre-attentive processing. It gets our attention there, and we can actually focus on those parts of the data. Now, let's look at this one. So since we wanted to focus on certain parts of the data, what do you think the orange dots really represent? Top performers? Any guess? So let me help. So maybe when you look at this visual, you might have typically, maybe not you all, maybe typically somebody who might see this visual might think that the orange dots, they are top performers. But actually the orange dots in this visual, they do not represent the top performers, they only represent the team B. Now the reason that it got misled is because the word top performers is written in the orange font, and also those dots that represent B, the team B, they are also in the orange color. So that kind of misled. So we don't want to mislead a user by these kind of features and get them into misleading data connections. So we want the user to get the correct data connections, and we want them to use not misleading font colors. Now here is a visual that is from a public Medicaid data set, and we have different variables over here. In this visual, we see them all in the same color. So basically we are focusing on colors, and you will see over here that they are represented now in different colors. So these are actually analogous colors, and when we use different variables in a data, we can represent the different variables with analogous colors. So analogous colors can distinguish multiple data series without clashing. And normally we use dark or bright red colors when you want to highlight something in the visual. So let's say for instance you had a line chart. So in the line chart, if you want to focus on a line, then you would use a bright red or a dark visual. So we use only a limited color palette though at a time. So let's say for instance that there is a skilled chef. So a chef will probably combine ingredients to make the delicious meal. A less skilled chef like myself will probably go to the freezer and get some microwave dinner, right? And microwave dinners are probably not that bad. But for this instance, let's say that you are the chef. So if you're the chef, the data set, the geometry, and the color, they are the ingredients. So color can convey additional dimensions, and color differences, they can be detected within 200 milliseconds before you're actually even conscious of paying attention, which is the pre-attentive concept that I earlier mentioned about. However, at a certain time, the human eye can only distinguish between few colors on a single visual. So humans cannot process many colors simultaneously in charts. So then how many colors should we use in a given single chart? Any guesses? 2, 3, 5. Okay. 4. Okay. So from my literature review, I have researched that humans can use no more than 6 colors in a given visual. So in a given chart. Now there are 3 different color scale options. So I was talking to you about different variables. How many variables you are representing in a certain visual. Let's say if you are representing just one variable in a visual and you wanted to use different colors, then you can use actually the sequential scale option. You will see in the sequential scale option, on the left side it is with less hue, and on the right hand side the hue is increased. And the second option, the diverging, that's more for positive and negative values. So if you wanted to represent a positive or negative profit, you could use that. And the third one, when data is not numerical, then you can use the qualitative scale option. Now, choosing the shades that are too similar, and it's a challenge to make comparisons. Even a narrow color span restricts the amount of difference between the shades, whereas a wider color span on the right of the sequential, you see, it makes it easier to see the differences. So this works in the opposite direction too. So a color span that's too wide can exaggerate differences, and if you do not pay attention to the context of the data, you might show patterns that look obvious, but that are not very significant. Talking about colors, we do need to account for color blindness as well. So it is said that nearly 1 out of 10 individuals do suffer from color blindness. So color blindness is mostly impacted for these individuals for colors of red and green. So you might think then that how are they able to use the traffic lights? Any guesses? Precision? Like you mean the order? Yes, correct. So they go actually by the order of the lights because they could not see the red and the green. Now for our data visual itself, we can use analogous colors like the one that I mentioned before with the combination of the blue, yellow and the green, or we can also use the light green or a dark red. So if you wanted to use red and green colors together, this doesn't mean that we can't use red and green, we can still use. So if you wanted to use them together, you can use a very light color, so you can use a very light green and you can use a very dark red because that is still easily distinguishable for most users. Here is an example of a bar chart. So I have often seen this chart many a times when I teach my classes, and I have always had trouble explaining. So today I'm going to try to explain one more time. So this will be an example of a bar chart because you see that here the axis for one, we can't even read those labels. I couldn't read it myself standing here. Then we also see that there are 4 different colors for each variable, and we just said that we don't want to do that. We also see that the 2 axes, they are not at the same scale. So maybe you can't see from the back, but the 2 axes are not at the same scale. We always want to scale them at the same level. This is an example of a bad pie chart. So if you have too many filters, if you have too many categories, you don't want to use a pie chart. In a pie chart, you should use only if you have 4 categories. In the first example, you see that there is more than 4 categories. In the second example, you see that those values, they do not sum up to 100%. And in the third category, you see that those ones are all similar values. So an alternative to the pie chart could be something like a stacked bar chart. You would want to use pie charts only when you want to show percentages. Here is another thumb rule. I classify it as a thumb rule for scaling it to 0. The reason I say that I classify it as a thumb rule is because there is some debate about the scaling to 0. There are some researchers who still think that it probably is not too mandatory to scale to 0 all the time, just because of a given situation when we may not want to scale to 0. However, I believe that we should do that because if you look at these 2 visuals, that they are the exactly same visuals, but because of the scale, we interpret it differently. And if we had to interpret it the same, we would probably take some time or we probably even miss that goal. So you see in the first one, it actually shows a greater difference between those 2 bars than on the second one, where the actual difference between the 2 bars is much lesser. So it would be important to scale to 0 because the visual on the right is what gives us the realistic difference between the 2 bars. Our next thumb rule is not use 3D charts. We might think that 3D charts are like really fancy, but we should not use that because when you look at this chart, you see that there is more prominence to the section that is closer to you, that is closer in the front. So you tend to give more importance to that. And this actually, because of that, we don't get the real analysis from that visual. So this is not an ideal situation. So we want to avoid using 3D charts. Here is an actual example, here's an example of a real visual of the 2018, the Major League Baseball. I'm not much into baseball, maybe you all are, but nevertheless, what I want to show you here is that there is less of narrative commentary, which is what I'm going to be talking about next. This is a visual that was published in a Stanford University paper, and here we see that the data visualizations can actually be enhanced by narrative commentary. By pre-attentive processing, which part of the visual did you first look at? Yeah, that guy showing that number. That's where we looked at first. After that, where did you look at next? The guy on the right, exactly. However, we want some more meaningful information to the visual, and so although the data speaks, we do know there is something, a sport, something going on over here, a game. We want to add some narrative commentary to the visual to make it more useful and to make it more meaningful. After all, one of the main selling points of visualization is that it should help you digest a lot of information at once. So in this format, the text conveys the story, the image provides the supporting evidence or the related details. Here are some chart suggestions. So for charts we use different chart types for different situations, and you will see the 4 different situations, the relationship, comparison, distribution, and composition. So the most common ones that I have seen are the relationship, comparison, and distribution. So typically for a relationship, we use scatter plots, and you see that the bubble chart is a variant of a scatter chart. For making comparisons, depending on the number of variables you use, but typically we use again a bar chart or column chart, and then we use distributions, we use histograms, and although I did have scatter plot on the right for the distribution, we use more of histogram for distribution and lesser of and more of scatter plot for relationships. So what or how should we then construct good visuals, right? So after all this, so we want to make sure that they comprise of these 4 different categories. One is function, we have second is form, we have third as integrity, and fourth is interesting, which means that function will let you see the trends and patterns clearly. Form means that they are visually appealing and well structured to attract the readers to hold their attention. Integrity means that they portray the data accurately. You don't want to, remember the visual, we don't want to mislead the users. We don't want to make sure that they get the correct data connections from the visual. And interesting, because we want to make sure that the visual is relevant and meaningful or reveals the new information. So as Steve Jobs famously remarked that design is not how it just looks and feels, but also how it works. So we want a truly aesthetic visualization in addition to be beautiful, to make sure that it expresses all the inexplicit features of the phenomenon. So a good chart metrics, which is provided by Harvard Business Review, states that we need high contextual awareness and excellent design execution, because that would lead to good charts. So when creating an information visualization, I typically follow through the steps such as to formulate the question, you gather the data, apply a visual representation, and it's also important to ask exploratory questions to increase the contextual awareness. And I just wanted to end on this note. So if you all don't have any questions for me, then that means I did a good job. Okay, thank you so much. Thank you for coming.
About your thing with pie charts.
Okay.
So there was a study.
As a backup, because it's essential I get audio.
Because this one is for.
Okay.
It'll be this.
I don't want to scare everyone away when I do this. Let's try it. Oh, need to.
テストバージョンです。こんにちは。
Okay.
All right. I guess that'll be my backup plan.
Yeah, I'll be the one on top.
So you'll be taking off this one. There's two mics. So
For record.
okay, so well, I just need to talk to you. I need to turn it, go off.